Good day and welcome back for the fourth and final part of our discussion on sequences. As a reminder, in our previous videos, we've introduced the limit laws and properties of interest for evaluating limits, and we've worked through several examples. What I'd like to do in this video is introduce some language and a property that will be of use for us later on. So let me begin with the terminology, and I realize it looks like there's a lot here in terms of kind of bulleted items, but it's all hopefully very intuitive. So remember, A sub n is a list of numbers in a definitive order. So typically when we're thinking A sub n, we simultaneously can envision this list, A1, A2, A3, A4, and so on. And very intuitively, what should it mean to say that a sequence, or in this case our list of numbers, is increasing? Well, as you go from one number to the next, they just keep getting bigger. So I'm going to go ahead and write this generally and just say, well, if an plus 1 is always bigger than a sub n, and this is for all possible values of n. So that's saying a1 is smaller than a2 is smaller than a3 indefinitely. Well, likewise, a sequence would be decreasing if as you move from one number to the next in the list, they're always getting smaller. So if an plus 1 is always smaller than the number in front of it. So for example, that would mean a1 is bigger than a2, is bigger than a3, and so on. So as you go along the list, each and every number in that list is smaller than the number that precedes it. And a bit of kind of unifying language here is we say a sequence is monotonic, or we might say the word monotone, if a sub n is either increasing or decreasing. And then the other bit of language is related to what it means for a sequence to be bounded. So the first is bounded above. So if we have this list of numbers, intuitively what it would mean to say that it's bounded above is that there's some number that's bigger than everything in the list. So a very intuitive idea. So mathematically we would say if there is a number, big M, with a sub n smaller than big M for all n values. So that's just essentially saying if we go down our list and look at every single one, they're all smaller than big M. And bound it below would just mean there's a number that's smaller than everything in our list. So in this case, there is a number, let's call it little m, with little m smaller than a sub n for every single possible n. So as we go down our list of numbers, we can definitively say each one of them is bigger than some pre-specified number, little m. And we'll get a nice concrete example in a moment. Finally, we say that a sequence a sub n is bounded if a sub n is bounded above and below. So now that we have this terminology, let's go ahead and apply it to a nice concrete sequence. So for this sequence 1 over n plus 2, recall this is a list of numbers with a definitive order. When n is 1, we have 1/3. When n is 2, we have 1/4. Then 1/5, 1/6, and so on. And in terms of the language above, what I'm going to ask you to do is to pause the video, give yourself maybe 90 seconds, 2 minutes, and determine, is this sequence increasing, decreasing, or neither? And is it bounded above, bounded below? And if it's both, is it bounded? Okay, so hopefully you've given yourself a few minutes to think about this. The first observation that we want to make is as we go from one number to the next, you can see that they're getting smaller, right? Dividing by something bigger gives you back something smaller. So how could we explain this? Well, we can say that 1 over n plus 2 is decreasing, and the reason it is decreasing is because if you compare a sub n, which is 1 over n plus 2, with a n plus 1. So note when you think of a n, whatever that subscript is, you see precisely where it goes in the definition of the sequence. So a n plus 1 would be 1 over n plus 1 plus 2. And remember, dividing by something bigger gives you something smaller. So that's all the justification we need. A sub n plus 1 is less than a sub n, which is precisely what it means for a sequence to be decreasing. All right. Furthermore, let's go ahead and note that this is bounded as well. Now, how would we explain that? 1 over n plus 2 is bounded because, and then we need some explanation. And look at our list, it's decreasing. So the first number in the list is going to be the biggest. So in this case, what we could simply say is that each number in the list is smaller than 1. And also, each one is positive. So it's bounded below, we have our little m value, and it's bounded above, we have our big M value. But this inequality is enough to give the justification that it's a bounded sequence. The last thing I would like to do is relate it to this language, introduce a property. So let me go ahead and create a little more space and write down the property below. So we have the following property known as the monotone convergence theorem. And the monotone convergence theorem, which I will always abbreviate as MCT, tells us every bounded monotonic sequence is convergent. So a very simple statement. Note it doesn't tell us what the sequence converges to, simply that the sequence does converge. So if we look at our example from above, 1 over n plus 2, we noted it's a decreasing sequence, which means it's monotonic. And we also noted that it is bounded. And we could easily use limit laws to determine the value of the limit, but just to illustrate the monotone convergence theorem, we can now know by the monotone convergence theorem, this sequence 1 over n plus 2 converges. And note it doesn't tell us the value of the limit, once again, simply that it exists. So that completes our discussion on sequences. And in our next video, we are going to move on to begin talking about series. And I'll throw out a disclaimer here just to let you know that the remainder of the videos for the semester I made for the last spring semester for when we transition to the remote learning. So I apologize in advance for all of those kind of comments, but hopefully at this point where we are now, we're feeling a little bit better about the situation and we can now look back at it in more of a lighthearted way. So that being said, remember, when you have questions, let me know. Stay tuned. Take care.